Go for it.
So thanks, students, for joining us for this pathway area. We'll be covering the electromagnetics area and also the circuits area in just a bit, but we will get started. So prepare to be electromagnetized by Dr. Constantine Balanis.
God.
Well, thank you very much for the kind introduction. I can hear some laughs in the background. Okay, repeating. ECE pathways, electromagnetics area, the foundation of electrical engineering, obviously. And I'm the presenter. And for those of you play golf, this is me at the tee box of number 7 at Pebble Beach, signature hole of Pebble Beach Golf Course in 2013. I haven't been back there since. Okay, what's electromagnetics? Electromagnetics is the study of charges, either at rest or in motion. The one charges at rest, we call that statics. And we cover that in EEE 241 here. Everybody in electrical engineering has to take that one. The one in motion, we call it dynamics, time varying. That's covered in EEE 341. Now, electromagnetics, the basis of electromagnetics are based on 4 equations, very basic equation we call Maxwell's equation. And I'll show you Maxwell's in a few minutes. And those Maxwell's equations are in vector form. They're very compact. And special cases of Maxwell's equations, circuit theory. When you analyze circuits, especially lumped elements using Kirchhoff laws, those are special cases of Maxwell's equation. Again, I will demonstrate that in a few minutes. Also, those of you that may take advanced courses in EM like EEE 541, geometrical optics, physical optics are special cases of Maxwell's equation. Who was Maxwell? James Clerk Maxwell lived in the 1800s. Unfortunately, very short period, lifespan of about 48 years. He was from Scotland, and here's a statue of him in Scotland. And on the bottom there, it's hard to see, it says James Clerk Maxwell. Well, one of my students that got his PhD at ASU, working out for Apple, visited Scotland. And he went to Maxwell's hometown and took a picture of his house. And this is the house of Maxwell. This is my student. And one of the bricks over here are Maxwell's equations in differential form. Now, let me show you what exactly that brick is. There it is. Maxwell's equation in differential form, standing in the house of Maxwell. Okay, so that's one set of Maxwell's equation in differential form, but we also have them in integral form. And those are 4 of Maxwell's equation in integral form. The first one has all the terms, it's complete. However, when we do circuit analysis, especially those using lumped element components like resistors, capacitors, inductors, this is representative of the loop equations that we do. However, in low frequencies, this last term, which I've shown here that cover, is small, and we do not include that. That term is not included in typical circuit analysis, low frequency circuit of lump elements. The next one is the node equations. in circuit theory. All the terms. The last one, again, is a term that for low frequency circuit analysis using lumped elements is very small. This is the one and is not included. So, however, when we do full wave analysis using Maxwell's equation, all those terms are included. Using, for example, nowadays with software, developed software includes all the terms. So those are Maxwell's equation. One, the first one, in integral form, the first one is, again, representative of the loop equations in circuit analysis. The second one is the node analysis of circuit theory. Why electromagnetics? I cannot emphasize, is the basis of electrical engineering. Number two, fundamental, challenging problems in many areas of electrical engineering. Wireless communication, and we'll show you some examples. Packaging of mobile units, such as cell phones. Stealth technology, and I have been involved in this for decades. Using complex and practical problems. Using what I said a few minutes ago, full wave techniques. Full wave techniques include all the terms of Maxwell's equation that I was showing you just a minute ago. We treat the problems as distributive devices, not as lumped elements. Modeling and simulated devices using full wave solvers. Those are software, and many of them around available. And others. Here are some examples of those devices, some older generation, and of course today's generation. You can see some of the ones. You see the one all the way to the right, the walkie-talkie. You can see the antenna, the exterior to the device. On the upper part, the first two on the left, walkie-talkie. It's one of the cell phone where the antenna elements, the antennas were outside the device. One is the StarTAC, the first one on the left. That's the Motorola, very popular during the 90s, for example. I had one personally. And then, of course, they took because of breakage and because of looks, they moved the antenna element inside the device. They embed it, as you can see on the lower, 3 of them. Looks better. You don't have to be worried about the antenna break or whatever. So all those have been designed based on using, let's say, software and Maxwell's equation in complete form. What study? Again, analyze, model, design, antennas, RF, microwave circuits, fiber optics, electronic packaging, EMI, electromagnetic interference, EMC, electromagnetic compatibility. Here is a base station. Here is a microwave circuit laptop, cell phone, stealth type of airplane, F-117, for example. However, to be successful in courses related to electromagnetics, we recommend people that have solid foundation of the following: mathematics, physics, circuits, and we'll talk about in a few minutes which courses in particular, because electromagnetics very mathematically intensive, as we showed Maxwell's equation in integral form, differential form. In other words, you have to understand vector analysis, need vector analysis. So because electrical engineers are, again, consider them engineers, not technicians. So those three, mathematics, physics, circuits, very, very important fundamentals for to be successful in and do well in electromagnetic courses and in a career in electromagnetics. So what are the prerequisite courses? One that all electrical engineers have to take is EEE 241, Fundamentals of Electromagnetics. EEE 202, Circuits 1, Physics 131, and Physics 132, which is the lab associated with Physics 131, the lecture. Those are prerequisites for all electrical engineers, no matter which area of electrical engineering you're going to follow, what the electives you're going to take. So the 241, the gateway course in electromagnetics, covers primarily static and also towards the end time-varying vector fields. And I try to emphasize vector. Okay, boundary value problems. Dielectric and magnetic materials. Dielectric, the one you have variable permittivity. Magnetic, the one you have different permeability. That's how you define the materials, or you represent the materials. Dielectric through permittivity, magnetic through the permeability. Permittivity, the epsilon, the permeability, the mu. Maxwell's equation, boundary condition, the differential equation. When you try to solve differential equation, depending on the order of the differential equation, you have a number of unknowns. In order to determine the unknowns, you have to apply boundary conditions, like you do in mathematics when you deal with differential equation. Prerequisite, again, I'll repeat here, EEE 202, Physics 131, and the associated lab 132. What are other courses related to electromagnetics undergraduate? EEE 341, Engineering Electromagnetics. And I'll talk about that in a minute. That's taught fall and spring, and even summertime sometimes, especially nowadays with online classes. Many of these classes are taught fall, spring, maybe even summertime. You have to check to see which one, and depends on enrollment, of course. This is primarily devoted to time-varying electromagnetic fields, dynamic or time-varying as well. Deals with the fields, waves in homogeneous and stratified medium. Homogeneous are the one that have the same permittivity or permeability, for example. Stratified is where the permittivity, you can represent it in layers. Each layer has different permittivity, permeability, or combination of the two of them. Transmission lines, waveguides, cavity, resonators, radiation, electromagnetic radiation, antennas. Because we'll show you some of the courses. This course has a lecture, but also has a lab that goes with it. Now, this course here, it's required for those that will pursue pathway in electromagnetics. In other words, they're going to take elective courses, and I'll show you some of those courses in electromagnetic, like antennas, microwaves, and so forth. And of course, the prerequisite to this one is 241 that everybody has to take in electrical engineering. So again, for emphasis, EEE 341 is prerequisite to take EM electives like EM, antennas, microwave, optics, and so forth. What are some of the electives that we've been talking about? Antenna course, antennas for wireless communications. We cover different fundamentals, parameters of radiation, elements, basic elements, dipoles, linear elements, loop antennas, or combination of those elements put together. We call those arrays, smart antennas, microstrip elements, very popular starting in 1970s. Also include measurements. We have a facility. I'll show you that towards the end of the presentation. Very, very popular course and especially in wireless communication. Antennas are the eyes and ears of a communication system. A human, if you don't have a good eyes, cannot hear well, cannot be efficient. Person cannot be efficient. Same thing in a wireless communication system. If you don't have a good antennas to transmit and receive information, the system cannot operate efficiently. Another one, very bad, the wireless, the guts of our communication system inside. Microwaves, EEE 445, again taught spring, fall, maybe even summertime sometimes. You have to check nowadays with online classes. Those courses, all courses, are more available. 448, fiber optics, another very popular course for senior elective course. All those right here, again, repeating, you need to have Tech 341. And by the way, 341 is a very fundamental course for wireless communication. I personally recommend that all electrical engineers take 341. You learn many things there that you will need in communications, in fiber optics, no matter which area of electrical engineering, even in solid state, 341, because we cover transmission lines, people in power area, talking about lines, transmission lines to transport energy from one place to another one. Okay, 341, recommended. Graduate courses, we have a slew of them. You can see here. And we offer them on a frequent basis, especially like 541, 543, which is the first one is 541 is fresh graduate level course in electromagnetics. Again, radar, microwave circuits, and we even have a 600 level courses. They're taught now. They're not taught as often as some of the other ones, but we have taught. That's why we have them, because we teach them. Graduate school, master's level, somewhat specialized, applications oriented. PhD, more specialized in a particular area, research and development, R&D, required for positions in a university, careers, academia, need a PhD, industry. I'm sorry, let me go back over here. Industry, bachelor's, master's, PhD. You can see some of usually what you do in each one of those in teaching, research, applications, job opportunities, all kinds of companies, especially in the Phoenix area. Many of them have facilities here in the valley, industry, government. And I worked for one of them, NASA, back in the 60s. Faculty, Professor Eberly, you've probably seen them. Myself, I'm a Professor Emeritus. I retired a couple of years ago. I'm still involved. Professor Imani, Professor Palais is also Professor Emeritus, Professor Pan. Some of you may have been exposed to some of this faculty, and of course, Professor Trikopoulos. Books, we have a number of authored by faculty, myself included. This is Antenna Theory. This was the 3rd edition. This is the 4th edition. The 4th edition is in color. This is the graduate level book that we use for graduate level electromagnetics, smart antennas. Again, a book I authored. I edited a book or a handbook on modern antennas. This is the book on fiber optics, authored by Professor Palais. This is a book on wavelets, authored by Professor Pan. And last but not least, this just came out just about 3-4 days ago. This is the 3rd edition of the Advanced Engineering Electromagnetics book that we use, for example, for 541, 641, and so forth. Facility, we have what we call the chamber, the anechoic chamber, EMAC, electromagnetic anechoic chamber, one of the top 2 such facilities in a university environment. We built it in middle 1980s, 85, became operational 85, 86. Okay, unique. Not many universities have such a facility, not only such a facility of that size. So, first some viewpoints. Why electrical engineering? Why electromagnetics? Why NASA? This is speaking of myself. It was there in 1960s, 64 to 76 years. I was a faculty member at West Virginia University, 70 to 83, 13 years. And lastly, at ASU, 37 and a half years. But besides being an electrical engineer, working for NASA, teaching at the university, I also mess around with golf. Not a good golfer, but enjoy. Now, if you want to know something about all those, the whys, electrical engineering, electromagnetics, golf, and so forth, you can go to YouTube. I've been interviewed in March of last year. It appeared on the YouTube on July the 19th, 2023, the Legends of Electromagnetics, Professor Constantine Balanis. You can go there, and if you have a hard time sleeping, this will do it. We'll take care of it. So, with that, I want to thank you for the opportunity to make this presentation, and I'll be most happy to answer any question as time permits. Thank you very much.
Yeah, thank you, Dr. Balanis. Students, if you have questions for Dr. Balanis, really about his career, his history, anything like that, feel free to throw them into the chat and we can facilitate those. But we like to poke fun at Dr. Balanis, but he is very accomplished, and we're super grateful that he comes to these, and you're all going to look at his book eventually, which is exciting. So we do have a question here. It says,
okay.
This Angel Torres is asking, does 341 generally cover the second half of the field and wave electromagnetic 2nd edition by Chang? So do you cover that stuff in the course, or do we?
Excellent question. Yes, yes, that's exactly right.
Yeah, so
341 is the second half of David Chang's book. We started probably in 1980s, and we had it until the last couple of years. However, the book by Chang is out of print. So switch into a new book, another book, I should say, by Ulaby. I believe is going to be the book that they're going to be using for EEE 341, and not only for EEE 341, but also for 241. I think the next question, it says, this was the text used in 241. It seems to stop halfway through the textbook. Yes, the first half of Chang's book, David Chang's book, was used primarily for 241, and the second half it was used for 341. By the way, that's not only Chang's book. Most all of the undergraduate EM books do exactly the same thing. Half of it primarily for statics or 241, and the second half for dynamics or time varying fields for 341. So we're trying to use one book for both of those courses.
Thank you for that. And a funny note about that, whenever a faculty leaves their office, Cheryl, who's on the line here, we often go searching around for one of those books. We go
I've
raiding
got
for them.
3 copies of Chang in my office right now.
So you
We
better
try to
keep them
hoard.
because you're not going to be able to find any in the future. So
They're not going anywhere.
then yeah, exactly. Take him with you.
Do we have
All
any
right,
other
any other
questions
question?
for? Yeah, it looks like we do here. This is Angel's asking another question. Do you foresee any issues with 5G implementation? He works in the electric utility area, and there are lots of conversations about setting the antennas on supply voltage plus 69 structures. Do you have any thoughts about that?
Well, I don't know that much about it, but 5G is the future for a while at least. And I don't know. This is an application in the power area. It looks like conversation setting up antennas on supply voltages. So I would rather not, provide any comment because I don't know that much about it.
Yeah,
But
Angel,
I
maybe
know
come by the
5G
power.
is the future of wireless communication for a while.
Yeah, Angel, I would recommend coming by the power pathway. That would be a great question to ask.
Yes,
So
a great question for it. Exactly. Yes.
yeah, he's saying line workers have to climb up to the next to the antennas. They're unsure of whether the power output will be an issue. And yeah, this would be a really cool question for the power area folks. And these kinds of questions and these kinds of specialties are useful to understand why, we always talk about EE being a very broad major, and it is, because when you want to get into these specialties, it really can go in multiple directions. So yeah, come by the power group. I'm not sure who's going to be presenting that day, but that would be a great question for that group.
Yeah, that will give you a better question, better answer, I should say. Yeah, somebody from the power area. Yes. All right. Any other?
Thank you. And you're getting a big thank you from Angel for your feedback. It's a pleasure to see your presentation. And he's congratulating on your recently published Wiley textbook, which now has Balanis's name in the title, not only in the author, correct? It's Balanis's Electromagnetics or something like that.
Yes. Hold on. We're going to do some. Hold on.
I think it's actually a cookbook. It's just his favorite muffin recipes.
I guess you can't see me. Yeah, I have a copy of it right here. I just got it about 4 days ago. Yes, it has I think again, this is, to my knowledge, okay, the first engineering book, science book that has the author's name on the title. Okay. Now, when the publisher made this suggestion to put my name on the title, I kind of resisted, honestly. And I said that if you read the preface of the new edition, and the example they told me, Gray's Anatomy. The example no, really, that's what they get to convince me, Gray's Anatomy. Gray, Gray, is the author and has his name on the title. So, yes, my name is on the title.
Well, I read the book, and I can tell you it was a fantastic cookbook, and I can make fantastic macaroni and cheese after reading it. So thank you for the change. It changed my life.
You know how to stab somebody. After all this nice comments, at the end of them, you throw them a stab. That's okay. I can take it. Remember, I'm from a distance. I'm not in the office. Okay. It doesn't hurt as much.
Well, thanks so much. And thanks students for dealing with our banter here, but we appreciate, I'm joking, but we do appreciate you coming to this. It means a
Of
lot to the
course,
students and
always.
Very
it's
much.
awesome.
All humor is good, part of life.
We will move
Exactly.
on to the circuits area, and unfortunately our circuits faculty on at last minute couldn't join us. I'm going to cover parts of that presentation, and if Dr. Balanis is still here, he can correct anything I try to say.
One minute. Did you say you're going to cover the lecture on the seminar on circuits?
Well, I'm gonna review some of the slides, and obviously
Why don't we continue with electromagnetics, the rest of it, instead of you presenting the circuits?
It's not a bad idea. I think the students might be expecting some of the content, so I probably should at least review the faculty in that group.
Maybe I'll do a better job if I do it.
I think you would too. Are
Well,
you willing to talk on some of these slides?
I don't have the slides, but I can do it without even the slides.
Here, let me put it up here. So this is
Go to it. Thank you.
yeah. So sorry, students, about that. We had a last minute cancellation, but the circuits area, and this is kind of an older presentation, but we should be able to get some of the most important information out of it. And if Dr. Balanis is willing to correct some of the areas that I talk about, or if he wants to take over, that's awesome too. But just a brief preface from my knowledge area, because I'm not an engineer. Circuits is the largest, most kind of, I guess, the most popular academic area in EE at the moment. It's probably the most, students are most aware of it because of the circuits are kind of what you guys are used to. But we have a lot of specializations within circuits. And as Dr. Balanis talked about earlier in his presentation, there's a lot of crossover. So to be a good EMAG faculty or researcher, you need to know about circuits and vice versa, that sort of thing.
Let me inject something at this point. I was undergraduate back in 1960s. Circuits and electromagnetics were required courses going back in the 60s. Both, you did not have an option. You had to take courses in circuits, 2 courses in electromagnetics. Now I'm talking back in 1960s. Yes, that's a true statement here. What this slide shows you, that circuits is very popular, covers many areas of, almost all areas of electrical. And by the way, circuits, special cases. Remember what one of my slides? Maxwell's equation in integral form. Loop equations, node equations are based on 2 of Maxwell's equations. Okay, now you can continue now.
Yeah, so these are some of our areas that we have faculty in that are doing specialization in. So we have an analog circuits area, digital circuits, VLSI. The point number 2 there, a lot of our international graduate students come here from all over the world to study with us. And often they're sponsored for permanent visas, and many of them seem to be being hired in this VLSI area that's very hot. So that skill that they can gain from our courses often leads to them getting work and visas, which is very exciting. The MEMS area, emerging devices and circuits, and then this RF and microwave systems and integrated circuits. So there's a lot going on. And also make note that the semiconductor, microelectronics, all that kind of stuff right now is very hot, particularly in Phoenix with the expansion of Intel's plants and TSMC, Taiwan Semiconductor, creating a fabrication plant up in the North Valley. It's a big deal. So here are some of our faculty, slightly out of this one's a couple of years old, so we kind of dug this one up. But we do have faculty in all the areas that we mentioned. So if you're curious, and then if you want to know more about this, our school's website has bios on all of our faculty. So if you're someone now, maybe you're starting to take 334 and a little bit after, and you want to learn more, feel free to reach out to any faculty and ask them about undergraduate research experiences or more, but these are the general areas. Most of the circuits faculty, if you're on campus, and I know we have a lot of online students here, but they're in the ISTB4 building, which is a really exciting building. Online students, if you come to campus and you, especially at convocation, if you guys come to that, make sure to stop by IST before. It's like a museum in there. They have wonderful things to look around. And Tempe campus students, if you haven't gone in there and looked around the first, second, and third floors, the exhibits there are pretty cool. So check them out. These are some of our applications. So I want to jump ahead to the curriculum just so you can see what it looks like. So mainly after you get through the 202, you'll jump into circuits 2, and then you'll move on. If you want to do more circuits, you'll take some. You could take circuits 335, and then after doing that, you'll branch off if you choose in one of the two areas, whether it's digital or analog. 333 is a course where you learn coding like Verilog and stuff like that. That's very popular. So these are the kinds of courses you take when you're choosing the circuits pathway as an undergraduate. At the bottom of the bottom half are graduate courses. So if you decide to stick with us for a graduate program or your 4+1, these are some of the topics that you'll learn about. I won't spend much time on that. Here are some faculty members, and Dr. Balanis, you can maybe help me a little bit with what this is, because the imaging and stuff might have some relation to what the EMAG folks do, but Dr. Turkopoulos is an EMAG person, but he does research into circuits in the terahertz area. Do you have any comments on what he does, Dr. Balanis?
Yeah, it's high frequency. Terahertz is way up, above microwave. So, but you're correct. He's primarily an EM faculty member, but works in the terahertz for different applications. Imaging, for medical security, non-destructive inspection, and so forth.
Yeah, so again, there's a lot of crossover between our areas.
Oh, definitely. All faculty members, as you can see, they more than just one area. Yes, that's correct.
Yeah, and so and the same kind of goes for Dr. Z, as we call him, Dr. Syed Z. And
yes.
He does a lot of sensing and communication type stuff, which obviously has a lot to do with electromagnetism. So it's all, these two areas have a lot of overlap. Some of the VLSI research areas we have are listed here. I won't speak too much on them, because but again, and then the VLSI areas I talked about, we do have a lot of people hired in there. But at the bottom here, you'll see where many of our students are hired. So some of the largest companies in the world doing the most important work in this area, our students are working at. So you've got a track record to get hired by these folks if you do well in this area. Neuromorphic computing, we have folks working on that area. I believe that's Professor Fan does that, and some others. Unfortunately, I can't give you too many details on that, but I want to share another. Professor Kitchen is a very well-respected faculty member in here. She's interested in RF transceivers and power management. So another example of crossover is circuits have a lot of power consumption, and there's a lot of interest in using, optimizing how power gets in and out of these things and what it does. So we have a power area, of course, but a lot of our power area folks are also interested in circuits, because that's a big component of what it is. Dr. Kitchen has a large research group that's doing really exciting stuff, just so you know a little bit more about our group. Dr. Jennifer Blaine Christian does really interesting things in the biomedical area. So a point on her, her research is, a lot of students at ASU come to, they want to work in biomedical fields, and sometimes they'll study biomedical engineering specifically. But I like to talk about her work because EEs can definitely be very leaders in the biomedical area. And in fact, sometimes they need someone with deep electrical engineering knowledge to make the stuff work. Dr. Blaine Christian has a lot of exciting research projects in the biomedical area. This is kind of more on some of her stuff. Yeah, so there's a lot of interesting problems her and researchers like her need to solve. So if you want to have circuits working on the inside of somebody's body or in an organ or in the brain or in a heart, you need to be able to do this by passing power at a very small way, in a way that doesn't make a person sick, and that you don't need to take it in and out all the time. So it's really exciting problems that our faculty work on in that area. I'm going to skip ahead. There's a lot of slides on this one. Now, and I know Dr. Balanis has a lot of experience with students leaving and going to work. I know he's worked in industry himself. This is a slightly out of date. It's been updated a little bit, but these are kind of where our students find work in the Valley. So this is a lot of Valley stuff, but these are some of the largest. I know Dr. Balanis has experience in the aerospace industry. You'll see some of those folks on there. One of my roles is to help the graduate students with their skills verifications when they go on to get work, and I see lots of Raytheon, lots of Intel, microchip, all that kind of stuff. Are there other companies on this list that we should add, Dr. Balanis? Any big companies that we're missing, you think?
Well, thank you, because I was going to jump in. Thank you. You read my mind. Yes, many of us came here going back to 1980s. I came in 83. At that time, local high-tech industry demanded that ASU have a good engineering school. They introduced what they call Engineering Excellence Program. Myself, Dr. Ferry, Dr. Schroeder, we came in here as a full professors because the commitment ASU made to upgrade engineering, because the demand from local industry. At that time, the Phoenix metro area was the second highest high-tech area in the country. The other one was up in the Silicon Valley at that time. ASU at that time, and of course, has jumped up considerably. ASU Engineering and University of California and Santa Barbara were considered the top two up and coming. Remember, top two up and coming engineering schools in the country because of the commitment ASU made in engineering. Local industry headed at that time by Motorola. Motorola was the largest employer of engineers here. They had 19,000 people in Arizona, most of them right here in the Valley. But Motorola kind of fell off the top a little bit with the cell phone because they pursued the analog option of the cell phone instead of the digital. Okay, what is now General Dynamics in Scottsdale used to be the Government Electronics Group of Motorola. Most of our students in classes, all of my classes taught engineering classes, especially electrical engineering, were coming from Motorola. We had a class in antennas, 120 students. Most of them Motorola. Again, I'm making a point for Motorola. Okay. So yes, I think, and then of course, we have all of the faculty in electrical engineering have students working for these companies. We have Intel, Raytheon is primarily, I think, in Tucson, but Honeywell, General Dynamics, as you show there, that used to be the Motorola Government Electronics Group, or they changed the name to Government Electronics Division. Okay, GGD. That's what they changed the name. Boeing, what it used to be, McDonnell Douglas, the building there about 4 miles from my house. The Apache. I went to the opening ceremonies for concerning the Apache here. IBM locally. Freescale was part of Motorola. It was split from Motorola. Orbital Sciences was very small, one building. If you go down Price Road, there are many buildings. Expanded, but it used to be Motorola. Orbital Science. And all other companies. Yes, this is very hot area in technology. The Phoenix metro area, many companies, and there are many more companies that I'm not aware of, very smaller companies and so forth.
Yeah, it goes on and on. Locally, we have
Yes, go for it.
Medtronic.
Thank you, I'm
We
sorry.
have students. Yeah, we have
Yes,
students
yes.
at TI all over the place. And so,
Yes. Mhm.
yeah, thanks. But you also brought up an interesting point about ASU and what we've done. I always like to remind students about what ASU is and where it is. So I know I'm from the Chicago area, and there's a university every couple of miles, it feels like. But ASU was kind of the demand when sounds like when Professor Balanis was hired was that we need to do more for the Valley. ASU needs to do more for the Valley to draw in industry, and we still do that. So you know, TSMC coming to town has impact on ASU. They want us to do more, and I know we have a lot of online students on with us today, and you know, when we went online with our programs, because we wanted to expand beyond Arizona, even we think we're trying to solve the problem of educating engineers just beyond Arizona now. We know the world needs more, and we're interested in doing it. So thanks for bringing that up, especially during your time when you started on. It was a big deal to have brought you folks on, new faculty in engineering, pretty much made the engineering school what it is today.
One more comment that we talked about the online. Because of the lack of internet, 1980s, ASU has been teaching what we call today online since 1980s. We used to call them TV classes because they were broadcast because of the lack of the internet only locally. We had 16 stations using a microwave link. We used to call them TV classes. Motorola had 3 locations. Intel had 2 of them. Let's say Honeywell, what it used to be, what is now the aerospace companies, throughout the valley. So we used to teach. ASU was one of the first ones to teach online classes. We used to call them TV classes. When I came in '83, there were radio on. I had 5 classes.
Yeah, imagine back in the day, so the online students, instead of using RP now for your exams, you'd be mailing your exams back and forth with the post office. That's kind of how it worked, right?
No, we had an office. ASU had the office, especially in engineering, where they used to do the handling, all the logistics of sending out, receiving and sending out homework, test assignments, and so forth. It worked very well. Never had a problem. Never.
Yeah. So, but we've been in the business for a long time. So yeah, that's a great reminder. Thanks. We didn't just kind of throw this thing together. We've been doing distance education for a while. This one's a little out of date, but again, the compensation by industry, this is quite out of date now, so I don't want to put too much focus on it, but those are large numbers. Those large numbers are probably median compensations, so people who've been in the field for a while. But they should show you that if you're wondering about quality of life after graduating with one of our degrees and where you'll go, people in our areas in this area do quite well, as they do for pretty much all EE majors. And this is the kind of degree that you can take you all over the country or all over the world if you wanted to. Of course, this compensation by location shifts, and I would say it's changed even more since this was published a few years back. For example, Arizona compensation has gone up, but so has the cost of living. So there's a whole economics game behind all that. But anyway, that was it for that. So sorry that our circuits faculty wouldn't be here, but good for you that you got more Dr. Balanis out of this deal. So and he was able to cover for us a little bit. But do you guys have more questions, particularly about circuits or anything like that?
Let me make one more comment before talk about electrical engineering. Very diversified. If you look at the Professional Society of IEEE, Institute of Electrical and Electronics Engineers, used to be called IRE. Can you hear me still?
Yeah.
Okay, thank you. In 1963, it changed the name from IRE, Institute of Radio Engineers, to IEEE, Institute of Electrical and Electronics Engineers, because there used to be before 2 electrical engineering societies. They merged into one, IEEE. IEEE today, to show you the diversification, has 39 specialties, 39 journals in associated magazines. Each professional society has its own journal or transaction. 39. So you get a degree in electrical engineering, you can find a job almost everywhere in a different area. You talked about biomedical engineering. You talk about power. You talk about communication. You talk about electromagnetics. Yeah, they companies here locally, for example. So the most diversified degree in engineering, electrical engineering, biomedical. You know, can you imagine electrical engineers doing work in biomedical imaging, and so forth? You talk about this kitchen and all those professors. You know what I'm talking about? That we now have. And by the way, electrical engineering, when I came, there were 25 faculty members. Now we have what, 60?
Oh, more
60,
than that. I think we're up to 75. Yeah, I think we're in the 70s.
Maybe. Okay. To show you the expansion, the commitment made by ASU to engineering, especially electrical engineering.
Yeah, our students do great stuff. It is one of the tougher degrees out there. So when you hit some of these courses, particularly 241, don't look away. Just study harder and stick with it. Our students do great.
You can find a job almost anywhere in the country, no matter how small the area is, no matter how big the area is. You'll find companies that hire electrical engineers. Okay, let's see if we can answer any questions.
Yeah, it looks like I don't have any questions yet, but if you have Jim V, thanks for putting the faculty by research area down. So students in the chat, our graduate advisor, Jim Vanderploeg, put in a link that shows our faculty by their research area. Really, that should be something that you should, if you haven't read that, just slowly read through each of them, even if it's not a research area like, it's just, it's great to know, you're paying for access to these folks when you pick tuition. So it's just useful to know who they are and what they've done, and it'll get your imagination going, what you could do with it. And he also put in a link to our graduate programs. So graduate students who earn master's degrees have a significant salary differential. They do better financially. Same with PhD. Philip's got a question here. If you're interested in doing VLSI, what are good undergraduate courses to take in addition to circuits classes? So the circuits path, obviously take as many of those as you possibly can do. But if you're looking at, VLSI stands for very large scale integration, correct? And I think, I don't know, maybe what else would make sense in there, Dr. Balanis? What else do they do? Like they have to know a little bit about optics, right, to understand how to do
well,
that.
I think, communications in the communications area, the VLSI people, communication. Even again, if you treated the devices as distributive instead of lumped elements, I think electromagnetics. I mean, I had to put them. I know I'm from the electromagnetics area. If you treated the circuit as a distributive circuit instead of some lumped elements, as you go higher, and you have to do that as you go in higher and higher frequencies, because you have to take into account, all these details concerning the circuit, for example. Then the electromagnetic, we talked about Maxwell's equation. There are a lot of software being developed, commercial software, that you can use, to do some of this more advanced designs to take into account all the effects.
Yeah, and I would say if you come to one of our other pathways, you can ask a similar question, because if you went to the because I talked briefly about it, even though I'm not an expert, but someone might in the power area, there's power applications, and they're not always just talking about power plants and nuclear power and generation. Sometimes they're talking about power into these tiny devices. And thank you, Dr. Balanis, for mentioning the signal communications and signal processing area, because that's a big deal. So right now, another hot area is data science. So, which has a lot to do with collecting signals and data. And that could have something to do with this area too. Again, I'm no expert, not pretending to be. I just kind of know what these faculty do and what they're curious about. So thanks, Philip, for putting in a content question there. Any others? Looks like Jim is reminding students about, if you're not poking around the Engineering Career Center site that he put in chat, look in there regularly, even if you're not looking for an internship or a job now. Be the kind of person who's always looking at what people are posting so you can prepare for when you are ready to go.
Yeah, a recommendation that they attend all the pathways. You know what I mean? This way you get a better understanding what each area is, what it's offered at ASU. For example, what courses they should take to be ready, and whether they should go to graduate school. And I highly recommend that they do. You can do it either full-time or you can do it on a part-time basis. You know, the special nowadays with the online availability of classes from around the world. For example, of course, we have ASU covers almost all of them. You can take classes online from a distance. Great.
All right, well, thanks everybody. We're about done on time anyway, but yeah, and we do have a bunch of online students who joined us today, and I special thanks to you guys for joining us for a live event while you're online. Sorry, our circuit faculty couldn't be here, but like I said, Dr. Balanis is more fun and interesting anyway. So thanks for being here.
Do I get paid twice? Do I get paid twice, or I just want to clear this thing out here before we sign off?
Yeah, I will talk to Dr. Phillips about that and ask I'll add it to my fee too.
The compensation, in other words, instead of it being, we don't take checks, we'd rather take cash because checks bounce.
Yeah, I know you'd like to keep that from the IRS, so I'll make sure.
Yeah, correct. That's another, yeah. You know about that, obviously. You must have experience. Thank you very much. Enjoy it very much.
Yeah, well, thanks again, students. Thanks for your interest in joining us.
Have a great semester.